live session today. And I'll just first I'll share my screen. And the first thing I'll do is here's a link which I'm going to share in the chat. So just go ahead and click this link, and this web page is going to open. This data set is by the Intergovernmental Panel on Climate Change, also called IPCC. And as you can see, there's this rotating globe. It has temperature, it has precipitation. So what we will do is, if you just scroll down, here's the simple thing, not advanced. We'll just go for the simple one for the time being. Just click on the simple one. And this page opens up. So before I go ahead and start explaining what the data is, can someone wants to give it a try? Like, what do they understand at the first glance? Anyone? It's totally fine. Like, just give it a shot. Like, what is your gut feeling say?
Warming.
Yeah, warming. Yeah. Thank you, sir. Yeah, so it's on warming. And now, but what kind of warming basically? Like, what type of warming? So as
It's a compared to the industrial age average, like when
yeah,
the industrial age is started, so pre-industrial age.
yeah, so thank you, sir. So this swarming, basically the temperature is not like, it's not like your, okay, so when the warm, so what do you mean by like this mean temperature change warming 2 degree Celsius at SSP 5 8.5, which is relative to the 1850-1900 average? What do you understand by that? Can anyone explain it to me, like what he or she understands by this? It's fine, but I just want to see like what is it that the class have in mind when they read this? I just want to understand like the psyche, like where we stand actually before I go ahead and start the class. Anyone? Or is it too
So,
technical for the
so,
class?
so
Yeah.
yeah, I know a bit. So this SSP 5 8.5 is a particular scenario, which is like the RCP 8.5.
Yeah, yeah.
And it is with respect to that the mean temperature change, which is like the compared to the pre-industrial age, is mentioned.
Anyone else wants to have a go at this? Okay. So what it says basically is CMIP6. Now CMIP6, so there are a lot of temperature models that scientists come up with. CMIP6 is one of the models that we are focusing on. Does it concern us? If you're not into temperature, it shouldn't. I'm just a data journalist. I'm not a scientist myself. So I don't worry myself with all these models and all. That's for scientists to worry who come up with these models. But just to explain what that is, it's a scientific model that scientists use. Mean temperature change, basically, as the name suggests. So it's the temperature change relative to the 1850 to 1900 average. That so your temperature change would be in comparison to the 1850 to 1900 or a 50 years average. And why this age? Because this is the pre-industrial era age. So that's why they go for this base. Okay. And when, like, okay, so what is the timeline for it? The timeline here is in terms of degrees. So we don't know when the world would be warming at 2 degrees Celsius. But whenever that happens, well, like whenever the world would be warming at 2 degrees Celsius, this map that you see now is how will that region on Earth be warming at? Okay, if I'm able to explain. And in a scenario, so scientists always consider scenarios. Okay, so this is SPP 5 8.5 is nothing but scenario in terms of how much emission would also be happening, okay, from these greenhouse gases like carbon dioxide, methane, and all those. So an SSP 5 8.5 is like when it's business as usual, as in like there is no curb in emission. There's absolutely no curb in emission. You can just go on doing your business. Your factories will just keep emitting, greenhouse gases. There is no cap, no filter, nothing like that. So in such a scenario, at what rate would your world be warming at? Like a region in the world would be warming at when the mean temperature of the world would be 2 degrees. 2 degrees more than the 1850 to 1900 average. Was I able to explain that? Did anyone have any issues following that explanation? Because this is very important, because until and unless you understand like what the data set is on, you will never be able to work. So that's the reason. Okay. Can someone just give me a thumbs up if the class is happy with the explanation? They were able to understand.
Can I repeat it again?
Yeah, so this data set again is basically so it's comparing the mean temperature change, of the world, of certain regions of it can be any place on Earth. It's comparing the mean temperature change when the world would be warming at 2 degrees. So that region would be warming at what? And that comparison is in comparison to the 50 years average of 1850 to 1900 in a business as usual or SSP 5 8.5 scenario. If that helps.
So that means, to simplify, if the world's temperature deviation from the normal,
Yeah,
okay,
yeah.
is 2 degrees Celsius
So,
above
yeah,
the normal,
yeah.
then how will my country look like? How will my country perform? At what rate?
At what
Okay.
rate?
It could be less than 2 degree, could be above 2 degree, could be anything.
Yeah, it could be a country, it could be your ocean, anything, whatever you think of, any place on Earth. That's what this map shows.
So this map shows in if you see India, it shows very light red, orange.
Yeah.
Okay, that's when you compare at a global level. But when you deep dive and see your own country, things may change.
Things may change.
Yes.
Things may change.
So compared to the world.
So when you start doing those micro level comparisons, that's when like you will get another picture of it.
So this is the indicator of how will your country or your continent warm.
Yes.
Okay, when the rest of the world is warming at 2
2
degrees
degrees
Celsius.
above the
above the
50-year average.
Sir, does it mean that when the temperature will rise 2 degree overall,
Yes.
India will be between 0 to 1 degree rise only? Is it?
We'll have to see. We'll have to see that. We don't know like by how.
No, the color intensity shows like that. Is it true or not?
Hopefully it should, like if the color shows accordingly, but we can only see the shorelines and we can see the east coast, west coast. We don't know what's happening in north of. So I mean,
so now that's the trick.
That's the trick.
You know, so I'm sure in this group of participants will have people from different states of our country.
Yeah.
Okay, but the rates may vary state to state.
State to state, yeah.
So that's the fun of it. You know, so this global map.
You're doing those micro level comparison, micro level analysis. That's when like QGIS comes handy. Like this data is very good to see and understand and everything. It's pretty simple that way. But when you want to get into the specifics of it, like Maharashtra or Gujarat, at what rate that state would be warming at, when the world would be 2 degrees higher than the 50-year average. That's where QGIS, the power.
For instance, Pulaha did 2 to 3 stories on how will the coastal cities be in the scenario.
Yeah.
He had done a story on Kolkata, he did a story on Mumbai. Okay, so every city has its own set of problems, and this can be used to project and work accordingly. So you'll be able to plan for you can adapt. You can create a plan for adaptation based on this.
Based on this.
Yeah.
Excuse me.
Yeah. Hi.
Yeah, I would like to know it's written REL dot to 1950 to 1900, 1850 to 1900. This is some reference point timeline we are talking about.
Yeah, this is the base year, like the 50-year base period on which the temperature rise is calculated. And why this specifically 1850 to 1900 is because this is the pre-industrial era. So that's what scientists go for. Like when they're doing any sort of modeling when it comes to temperature rise or anything like that, that's the base year for most of the time. That's the base year that they use, the denominator that they use basically.
Thank you.
Yeah. Okay, so now we will go ahead and a couple of things before we actually download this. So like in the variable, just keep it to mean temperature. Your variable would be mean temperature in atmosphere, as you can see. Your quantity and scenario would be change, not value, change, and it will be warming 2 degrees C. Okay, warming at 2 degrees C. And your season would be annual. Okay, your season would be annual. So three things. Your variable would be mean temperature, your quantity and scenario would be warming at 2 degrees, and your season would be annual. And the way you download is you come here, see this is the download button here, and you click on that, and you have a couple of options. Now download as netcdf, download as PNG, download as GeoTIFF. Now we can discard PNG because PNG doesn't help us because PNG cannot store any geographically referenced data. So that boils down to two options, either download as netcdf or download as GeoTIFF. Now netcdf and GeoTIFF are the two most common data formats, raster data formats that you will come across when you're working in GIS. There are other data formats as well, but as far as I know, I mean, since I've been working, these two are the most common that I come across. So this is a very good way of learning how to, load either a netcdf or a GeoTIFF. So now, and what's the difference basically between a netcdf and a GeoTIFF is, so GeoTIFF, what happens is it's more like a two-dimensional data. It has X and Y. So the data is stored in X and Y variables. Okay. A netcdf is multi-dimensional. What I mean by multi-dimensional is it has X and Y for a place, but it also has that time dimension to it. So like you can store data as per your time. Okay. It can be hourly, it can be weekly, it can be monthly. So that's the difference between netcdf and TIFF. Another example of it is like most of the time what happens is modeling data where scientists are modeling something based on an algorithm or something. That's when they store it in netcdf. Otherwise, like if we have a topography data, that would mostly be GeoTIFF. So for the time being, we're going to focus on GeoTIFF, but you can also go ahead and download netcdf. It's totally fine because both the data for this data set, it's the same. So it's not an issue at all. So whatever like you want to, I'll go with GeoTIFF. So you can click on download as GeoTIFF. I'll just give it a permission just in case if anyone's having any issues with downloading it. Yeah, so that downloaded, and I'll just unzip it here. Yeah. And now let's get back to QGIS. So I'll delete everything from the last class. I'll start fresh. And the way you load a raster file is, I think the folder name was CMIP6, if I'm not wrong. So let me just.
So now you're talking about raster data.
Yeah, we're talking about raster data, and I'm
That's
going to
it.
show what is the raster data. I'll explain it. IP6. Here's the map diff. This is the one that concerns us. There's also another file called consensus.diff. I would encourage you to just explore it in your own time, like whenever you are going through QGIS, when you're working on QGIS. The one that we will focus on is map.diff. So again, we'll just drag and drop, drag it from the browser and drop it in the layers panel. And look something like this. I'll show it again, how you do it. I'll delete this. I'll again drag and drop here. Okay. That is the easier way. The official way of doing it is if you come to manage layers toolbar, the second option, add raster layer. Okay. And I'll click on raster layer. You come here, need this, sorry. Start. Okay. Click on this add raster layer. Click on this raster data set. You have these three buttons. click on the buttons. There's a CMIP6 map diff, open and add. So I'll just.
Sir, excuse me.
Hi.
The downloaded file is a compressed file. Do I need to
Yeah, you have
extract
to.
it here?
Yeah, you have to unzip it or extract it. Yeah.
Okay, thank you.
So I'll show once again in case people missed out. So here you have the raster. This is the official way, by the way, the add raster layer. Click on that.
Excuse me, sir.
Yeah.
So this panel where you are choosing add raster, it is not my application.
Yeah. So if this one is missing, then come to view, toolbar, and just check on manage layers toolbar. Okay.
View.
View toolbars, manage layers toolbar.
Okay, sir.
And now you come to this option, add raster layer. Click on that raster data. Here's the folder, mapdiff, open, add. That's the official way. Okay, and now we need some boundaries. So right now we can make out, okay, this is South America, this is North America, this is Africa.
So you mean the
India is
political
right
boundary?
here.
The political
Let's see what kind of boundaries, like political boundaries, country boundaries, continent boundaries. So let's see what kind of boundaries. So for that, what I'll do is I'll share a link first. Here's the link. Just click on the link and this page is going to open up. This data set is on continents, world continents. We'll be looking at world continents. And this data is by this GIS company called ESRI. They have other data sets as well. For the time being, we'll focus on the continent data set. And what I would like you to do is click on download, and this is going to open, and you can see CSV, shapefile, GeoJSON, KML, Geo. So these are the different kinds of vector data that you can work on. Okay, I just wanted to show you this because you have so many options when it comes to vector data. You already know what's a CSV. You already know what's a shapefile. What we are concerned with is today we are going to work on GeoJSON, which is another form of vector.
Pula, the file is the site is not opening.
Oh,
Page not found is the message comes page not found.
It's opening in my system.
is anyone else having this issue? I'll just share it.
I could download it.
Yeah,
My
but-
computer, it is not opening. All other sites are opening. This site is not opening.
The system, they have blocked it.
Yeah, your system, if you can just give it some permission, I think.
Permission, yeah, assure us the site is opening.
Oh, it got opened. Okay.
Yeah.
Okay. So once you're in this page, just click on download and this left-hand panel is going to open. And now you know CSV, you know shapefile, but we're going to ignore those two. We're going to focus on GeoJSON today. I just want you guys to get familiarized with as many data formats as possible. Okay, so that's why we're going to work on GeoJSON. And what is a GeoJSON? A GeoJSON is again sort of vector data, except like GeoJSON, we use GeoJSON a lot on web cartography. Okay, so that's why we are not that we are going to do web cartography, but web cartographers they prefer working on GeoJSON because the web page doesn't understand the shapefile. Okay, it doesn't understand that. I won't get into the details of why it doesn't understand, but they prefer GeoJSON for this reason. And it's also good to just like be familiar with as many data formats as possible. So just go ahead and click on GeoJSON download. And it's going to download this. And I just wanted to show you how it looks, how the data looks something like this. If you open it in a text editor. in your notepad or anything, you will see the data is stored in this map. That's a GeoGSON file. So anyway, going ahead. Again, now we are going to get some boundaries here. So what's the file name? World continents. So we're going to navigate to world continents. World continents. I'm going to drag it here. Yeah. And now I'm going to show you the difference between a vector data and a raster data. So why these two data sets?
Excuse me, in which format we downloaded this world continent?
GeoJSON.
Okay, thank you.
GeoJSON, yeah.
So if you just quickly tell me how you added the map, because I didn't have the tool that time.
This world
Yeah.
as the raster data.
Yes, sir. Yes.
The raster data. Okay. So you have this manage layers toolbar, right?
Yes, sir.
One thing is like the unofficial ways you can just drag it from the browser column. Just drag it like we do with shapefile then.
That right?
Yeah, you can drag it. That's the unofficial way. The official way is if you come to add raster layer, you click on add raster layer, click on this button and see where navigate to where you have saved the file and the file is going to be map.tif. Click on open and then just go ahead and click on add. Okay.
Okay.
Okay. Yeah. So yeah. So I'm going to show you the difference now between a vector layer and a raster layer. And the difference is if you start zooming in now, you just start zooming in, you see the background, you have the raster layer, which is in black, and the vector layers is in yellow. Now, if you see the difference, uncheck it, like you see, the more we zoom in, the raster layer starts pixelating. You see these grids, it's pixelating. It's not as smooth as the vector layer. And no matter how much you zoom in the vector layer, it's the same. The quality remains the same. There's no compromise on the quality, no matter how much you stretch it. But if you zoom into, say, raster layer, you see, you can just make out these small boxes because it's stored in grids. The data is stored in grids. That's why it will pixelate. So that's the difference between a vector layer and a vector data and raster data. So first thing first, what I'll do is I'll do some styling, and the first thing is, and how you do styling is world continents, this is the vector layer. If you have to make it transparent, like right now it's yellow, I don't want any color on that. Right click, properties, it'll come under symbology. So all the styling happens in symbology, okay? Anytime you want to color something, symbology is the place to go. Whether it be a shapefile, whether it be raster data, this is how you do it, symbology. You come to single symbol, simple fill, you click on that simple fill, and this is going to open up fill color. So now if you click on this small triangle here, fill color, and just drag the slider like this, just drag it, it will go transparency, it's transparent now. If you want to change the stroke color, just go ahead and change it. Just click on that wherever you want to place the slider. I'm happy with black for the time being. And I'll hit apply. Okay. See, now it's transparent. And we can make out the boundaries for the time being, but it's fine. Like we'll keep it to black for the time being. At least we can make it out. Like, okay, this is Europe, this is Asia, this is Africa, hopefully this is Australia, like that. So long and so forth.
So please repeat this step.
The how we make it transparent, right?
Yes.
Yeah. So go to vector layer, right click on.
Also, where you get this world continent thing?
So I had shared the link with you in chat. If you see the ESRI link, I'll just share it once more. So just go ahead, click on download and download GeoJSON, okay?
So that I have done, but in downloads, I'm not getting in this name.
So you have to see like you have to navigate yourself.
Scroll down. So in your browser panel to be
Yeah,
down.
in your browser panel, you can just see like wherever, and in case the browser panel is missing, you can just click on this button called refresh button, and then it will show you the latest file that you have also downloaded. So it'll reflect that latest change in the browser in your directory.
So where she has stored it, that's what matters, you know. So,
Yeah. So it could be a C drive, D drive, E drive.
Oh, so I have made one folder, GIS.
Okay, so just follow along for the time being. Just follow for the time being. So yeah. So now going ahead with so was I able to was someone asking for how we made it transparent, right? So click on properties, simple fill. It'll be in single symbol symbology, single symbol, simple fill. Click on that and just click on the fill color and just drag this slider. If it's 100%, just drag it to 0%. Okay, and click apply. Okay. So that's that. And now let us just like make it a little more legible, the data itself, like which is the raster data. Okay. So again, like what we are going to do is right click on map, properties. So there are a bunch of types of visualization that you can do in render type. Under band rendering, again in symbology, when you click. So raster data, the styling will be a little different compared to your vector data interface. It will be under band rendering, render type. I would encourage you to go through all of them, like what all they do. But what we are focused on is the single band pseudo color. Okay, single band pseudo color. And once you click on that, so it shows the minimum and the maximum, and what we will do is we'll just like color it accordingly. So the color ramp, click on that, all color ramps. And I think I'll go with yellow, orange, red, or just red, whatever, except like the diverging data set because it doesn't have any negative values. You can just try out and see how it's looking. But one of the things about data visualization is you should choose your color accordingly, because we're not going to go for blue, because it's not, blue doesn't denote water, or blue doesn't denote blue mostly denotes water, sorry, my bad. Blue mostly denotes water, but it doesn't denote warming. So we're gonna go for a color which is closer to symbolizing what's warming is. So probably red or yellow, orange, red. Let's see, I'll go for yellow, orange, red. Click on that. And so by the way, you can see all the color scheme, like how it's going to look. And then click on apply. Okay. And now you see, now this gives a good picture of how the warming will look. Anyone wants to have a go at like what they're observing right now? Like which areas on Earth would be warming the most when the world would be warming at 2 degrees higher?
Polar regions.
Sorry?
It's more polar region, not poles, right?
I can't make out what you're saying. Can you just come again?
North Pole, North Poles.
North Pole. Okay. Yeah. The North Pole. Yeah, the North Pole. And I'll just show you one quick tip. Like you can actually, investigate each and every box, each and every grid, how, like what the data stored is like. And what I mean by that is if you zoom in and say, I want to investigate like this particular box, okay, like what is the data, what does the data say here? And the way you do it is, in case this one is missing, this button is missing, what I'll say, what I'll show you is just right click, and under toolbars, just check on attributes toolbar. So let me just uncheck. So now it's missing. Okay. Now if I right click, just click on attributes toolbar, So this button is going to be visible. Click on that at this is identify features button. It's called an identify features button. Just click on that and just click on this box. And you see something like identify results. This panel opens up and it says band 1.97. So that's the value. So this box is basically 1.97 degree higher than its 50-year average. So that's how you can also individually just like investigate things. You can just check another box here and it'll show you 1.75, something like that. Let's see, like I think Bombay is somewhere here, Mumbai and Mumbai South, and the coastline is going to be 1.65. So that's how you can do it. Like that's how you can check individual boxes. But we are not concerned with individual boxes. We want like for the whole world, like how every continent looks like. How every continent looks like. Okay, it's like how at what rate would Africa be warming at what rate would Asia be warming at, and Asia would be made up of also India and all these areas. Like this is the boundary for Asia, this is Australia, like that. And this is called quantifying spatial data. We did that with fire activities. If you remember, we actually counted the number of fire activities, and this is again another type of quantification that we are going to do. We are going to calculate the mean temperature rise of every continent, and let's see what that picture throws. So we are only going to be concerned with the land surface. We're not going to do for the water or like these red areas, because that's mostly going to be water. And the way you do that is, the first thing is, how do you quantify a spatial data set, like calculate the mean of a data set. Now, the way you do that is come to raster here. There's the option raster, it's just next to vector, raster. And does it show? Okay, it shows. Okay, so my bad. The way you do that is you come to processing, toolbox, and search for zonal statistics. Right, just double click on zonal statistics. I'll show you once more. Just right click, left click this. Come to processing, toolbox, zonal statistics. So there'll be raster layer zonal statistics. Just go for zonal statistics. That's it. So your input layer is going to be your world continents. It's always going to be, your input layer is going to be the vector file, the boundary on which they are going to do the calculation. And the raster layer is going to be, as the name suggests, like the map thing, that is the data that we have. So if you get confused, always remember, and it's pretty self-explanatory, when you see the raster layer, that's going to be the data set that you're working on. And the input layer is which boundary you want to calculate it on. So say you have two boundaries, one is the world continent and the other one, world continent, and the other one is world countries. Now it depends on which data set you want to calculate it. Do you want to calculate on the continent, on a continent basis, or on a country basis? So that's how you select that. And one last thing is statistics to calculate. We are only concerned with when you just right click on these three buttons. We don't want count, we don't want sum. We are only concerned with the mean of that continent. Like what is the temperature change going to be, the rise going to be. So that's going to be mean. Go back and click on run and close. And it creates a file called zonal statistics. Now, before I go ahead, any questions?
Yes, can you repeat the steps once again, because some people are asking.
Yeah, okay.
So,
Yeah.
how you did this mean and that I missed.
Okay. So I'll just delete that once more, zonal statistics, and I'll just show the steps once more.
Oh, also the renderings are like, yeah, how you brought these colors here.
So yes, sir.
Okay, so if you come to map, first thing, I'll just show you the render type and then I'll show you the zonal statistics. So for the map, so right click on map, properties, symbology, and in the render type, you can say single band pseudo color. Okay, keep everything the same. In the color RAM, just come here. This is the triangle. Just click on that, and this thing is going to open and come to all color RAMs, and then you can choose the color that you want. Okay. But my only suggestion would be such, so just color it according to what the data is, right? So it's warming, so it'll be better if you can have shades of red or brown, something like that. So
Is the step clear till here? Are you on the same page?
Sir, how you get this band rendering in symbology?
So in symbology, you have the render type, right? Render type.
Left hand side, top right, left.
Single band, so if you see like you have multi-band, paletted, unique value, single band, we are concerned with single band pseudo color. So it's a band rendering.
I do not have those options.
You have to go for the map dataset. Are you on the vector dataset by any chance?
Graduated and something.
Yeah, so you're on the vector dataset. Just click on the map, right click on map,
Wait.
right click on map here, right click properties,
Yes.
symbology,
Yes.
and render type single band pseudo color.
No, sir, this option I'm not getting.
Are you on map or are you in world continents?
Sir, I'm on the world continents.
Yeah, so I told you to be on the map.
That's a mistake, Rajni. So
Yes, okay.
So be in the map, properties, under symbology, go to render type single band pseudo color. Okay? Yeah.
Got it.
So now come to processing. Now for the zonal statistics, like how zonal statistics is nothing but like how when we're trying to calculate the mean of an area or the whole file, like that.
right on the menu, it's on the top right side.
So here's the processing. It's between mesh and window processing. Click on processing, toolbox, and just search zonal statistics. Zonal statistics. And the first option, zonal statistics, not the raster layer zonal statistic, just zonal statistics. Right, double click, and this page is going to open up, and your input layer is going to be a world continent, and your raster layer is going to be map. Okay, your raster layer is going to be map, and the keep everything the same. We are not concerned with that. The statistics to calculate, just click on this 3 buttons, and you have just uncheck count, sum, just keep the mean checked because that's what we are concerned with. The mean, it has a bunch of other statistical variables that you can calculate, like variance, variety, range, all these things. But we are just concerned with mean. Now go back and now run. Okay. Click on run, and it's going to do the processing, then close, and it's going to create a file called zonal statistics. Is everyone the same page here? Any questions before we go ahead? Okay. Okay, so I'll just go ahead, assuming everyone was able to follow this. And the first thing I'm going to do is, how do you check the data now? Okay. So open attribute table. And by the way, like just before we look at the data, what do you think, like which, just give it a try. Just have a look at this. I just made this transparent, the zonal statistics layer. What do you think, which content would be warming the most? Like after having a look at the data, just the raw data itself. Like, and will anyone wants to give it a try? Will it be Asia? Will it be Africa? Will it be North America, Europe? Anyone?
North America.
North America?
Looks like North America.
Okay, so let's see now.
Didn't understand your question.
So I'm saying like which continent would be showing the maximum temperature deviation?
So
Deviation
it's
from the-
That we already discussed. North Pole, it's showing North Atlantic.
I'm asking about the continent. I'm not asking about any area. I'm saying which continent. Will it be North America, South
Europe.
Europe? Okay, we have an answer. Europe.
Europe.
Who else wants to have a go? Who else? Who else thinks it's going to be Europe?
I also
How
think it's Europe.
many people think it's going to be Europe? Can you just write it in the chat? Let's see. Before we actually see the data ourselves, let's see what people think. Okay, we have Antarctica, North America, South America, Europe. Still a lot of, okay, to North America. Okay, so now we'll see what's the answer going to be. Okay, and this is the power of QGIS. You can get into the specifics and you can actually say like what's the mean temperature going to be. You can get into that detail. Like instead of just saying in range, oh, it's going to be 0 degree to 1 degree, we can actually say whether it's going to be 1.5, 1.7, 1.2, like that. And the way you look at the data now is, now you come to zonal statistics, right click, open attribute table. Click on that, and here you have Africa would be at 2.4. Africa would be at 2.4. So it'll be warming more than the world, by the way. So it's already hot, and then it's going to be warming 2 degrees above its 50-year average. Asia would be 3.15. Oh. Australia would be 2.17. Oceania, Oceania is this one, I'm guessing. Yeah, it's mostly New Zealand and all those areas.
Australia.
It's 1.64. South America would be 2.25. Antarctica would be 2.27.
it's not
Someone get Antarctica, right? So here you go. Here's your answer, 2.27. So now let's see. Europe would be 3.24. And North America, so North America would be warming the most, by the way. Highest.
No
It's
doubt.
going to be 3.45.
Mr. Trump.
Mr. Trump. Yes, of course.
Everything.
Anyone from America, by the way? Anyway, we like your president, just in case someone's from America. No personal issues with that person, but yeah. So that's the data here. So that's how it's going to be. And these are the kind of, the specific details that you can get into.
This doesn't mean that we are at a better position because these are just the average figures.
These are just average figures. So high chances that this area would be, this region would be warming more than say somewhere like here, which is Louisiana. I'm guessing this area is Louisiana, this is Florida.
India.
Even within India, yeah, even within India, we have to see what, let's see. But yeah. And any questions? How we did it, what we did, why we did, what we did.
Then what about the color intensities? See, color intensity shows that North Europe and those will be much hotter, and Asia, South Asia will not be much hotter. So,
Yeah.
if we see attributes, then it shows higher temperature.
Yeah, because that's because when they are calculating the mean, so they are calculating the mean for the whole area of Asia, okay, and that includes South Asia as well, that includes Russia as well, parts of Russia, China, this area is the Tibetan Plateau. So they're considering Saudi Arabia as well. So they take everything into account before they give a mean number for it, before they do the calculation.
Okay, so it's average of average continent-wise average.
Yeah, average of the whole of Asia. not like us, because you're not doing this country wise, you're doing it continent wise, so you have to keep that in mind. Okay. And the
Got it.
continent, so the continent would be based like that, like, this is what they consider as Asia, so they're going to do the calculation based out of
That's
Asia.
an indicator. Mean is an indicator in this case.
Yeah, mean is an indicator in this case. Like, okay, so the average temperature
Alerts
rise in Asia is going to be around 3.15.
What's you?
Yeah. And now between Asia, and this is where you can come up with a lot of stories. Between Asia, you can also show the deviation. Like, okay, China would be warming at this rate, India would be warming at this rate, Saudi Arabia would be warming at this rate. So on and so forth.
How do we do that?
So that's going to be your assignment. That's going to be your assignment, that you're going to follow the same.
Okay.
So, very good question. And that brings us to what your assignment is going to be. And your assignment is going to be this, but country-wise. So, whatever we did, so all the steps are the same. And just one thing that I'm going to flag now is, if you see, like when we did the zonal statistics, we did not get that error. So we didn't have to fix the shapefile, right? Or the GeoJSON, sorry. We didn't have to fix the GeoJSON, right? Unlike in the first class where we had to actually fix the shapefile before we went ahead. So high chances, if you're working on the same country data file that we worked on, that we downloaded from Natural Earth, you're going to have to fix it before you quantify. Okay.
I
Now, I
didn't
know,
understand. See, I understand that we have to fix the shape file if error is there, but
yeah.
I don't understand why the error is there. Why shape file is not always in
Yeah, so
public?
I'll be sharing an explanation over this. I'll be sharing an explanation over this. Just go through it. I'll be mailing it to everyone, so all the participants will have it in case like why they want to know like what is the error. Mostly what happens, sir, is sometimes like when they're making the shapefile, there might be some intersection, like 2 points would be intersecting, but 2 points are, they might be having errors. So that's why the whole shapefile will be giving errors to you when they're trying to do some kind of calculation or something. To answer it as most beginner friendly level, but I'll share the whole explanation with you, and that will the confusion, like that will answer your query. Okay?
You mean it's the error at graphics level when preparing vector file? Is it?
It's error from the shapefile. Like the way when the shapefile was generated, maybe some points were edited, like some lines were edited, and when they were trying to edit that line, maybe So what I can tell you is like say this is a straight line, right? Like here, this is the straight line. Straight line as in like it doesn't intersect anywhere, right? The chances might be like what happened was this line might have just moved up to here and the whole area got intersected. So it's not like one smooth line. Okay. So it got intersected here. So that's why maybe the arrow. Most of the cases, that's what happens. Most of the cases. But I'll again, like I'll share I'll share the explanation with you
So does
regarding
it
the
always happen?
like out of 9 out of 10 times.
Yeah, okay.
9 out of 10 times. The continent one, we were, we're just lucky that this one had no errors in it. But most of the cases, you will come across that, and no matter what you do, like what kind of calculation you do, or any other thing that you try to do, you have to fix the shapefile before you start doing all those things that you want to do. So that step is very, very important. And most of the time, we are going to do it on a district level, state level, country level. So yeah,
So there's high possibility of these errors, and that's why you need to fix it. But
that
if you're very, very lucky,
yeah,
then
like
straight
this time, like in this case, like
So,
the continent one, this one doesn't have any issues.
how do QGIS know that the vector file is not fixed and I have to fix it here, I have to fix it here, I have to fix it here?
Yeah,
How
so
do QGIS know?
yeah, so that's why, sir, that's why you have. So, firstly, how do we know it has a problem? We don't know it has a problem. We only get to know that the file is having some issues when we are trying to do some kind of calculation, and the process is getting flagged by QGIS saying that I can't do this process because there's some issue or some invalid geometry, as like that's the term that QGIS uses, that we have some invalid geometry with the file. Okay, that's the first instance where we get to know, okay, this file has some error.
That's
So
what my question is. How does QGIS know that there is problem with
so let me just answer that. Yeah. So now we get to know that we have some error. Now we ask QGIS to figure out that error. What is the error? So that's where the check validity step comes in. So when we are trying to fix a shapefile, there are two steps involved. One is the check validity. The check validity identifies the error. So, okay, what is the error with the shapefile? It can be invalid geometry, it can be something else, but most of the time it's invalid geometries. So now QGIS know, okay, so now we have some invalid geometries that we have figured out. The places are normally here, like whichever place on earth that they find there's some issue with the polygon. And then finally, once they have identified those errors, like where those errors are, that's when we ask QGIS, okay, now you have fixed the error. Now you have identified those errors. Now try to fix it. And that's when QGIS gives us a clean copy of that vector file. That answers your question?
partially, but see, to know whether the fixed geometry is needed or not, QGIS need to relate with some standard. Then only it will know that there is error or there is no error.
So that's what I'm telling you. How do we know that there is an error? How do we know that there is an error? See, forget QGIS. QGIS is just a machine. It only needs our only explicitly when we ask QGIS to do certain things, only then it does it. Okay. So there's no way for QGIS to understand. First, we have to understand, okay, there is a problem. And the way we detect that problem is when we are trying to do some sort of calculation. Like in this case, we tried the zonal statistics, like we were trying to calculate the mean. Now, had there been some error with the shapefile itself, that's when the process will also throw a red flag saying, okay, there is some invalid geometry over which area I can't process the calculation that you're asking for. So that's how we first figure out there's an error with the shapefile itself.
So only when start processing, you come.
Only when we start the process of calculation, do we get to know that there is, okay, so there's some invalid geometry with this shapefile.
So what calculation does it do, and how do it compares the calculation?
So you were in the first class, right? We tried to count the number of count the number of points in a polygon, like the fire activities.
Yes, I was there. Yes.
Yeah. So if you remember, like we were trying to count the number of fire activities points in a polygon. A polygon can be anything. Okay, so that's a calculation in itself. We are trying to do a count calculation.
Okay.
So,
Excuse me, sir.
Yeah.
Yes. When the errors are identified, how do you fix the errors?
Yeah, so you just go for fixed geometries, but this is all there in the first class. So I'll just suggest you to just go through the recorded sessions again to answer your question, because all these have been taught in the first and the second class. If you still have any queries, so can you just mail it to me? Well, I'll just like go ahead with the class now.
Okay, thank you.
Yeah. Okay, so now we have the data, and we're going to export it. And before I do that, I'm going to show you one thing. Is now in this case we are not working on Arctic Circle per se, but say had the story been about Arctic Circle and you only wanted to focus this region. Okay, how do you do that? Now QGIS, now we have talked about projections, but QGIS doesn't have an automatic Arctic Circle projection like that, so we have to make a custom projection, and that's where AI comes in, because now the step has become very smooth. All I'm going to do here is I asked AI, the question was, and this is from Claude. This is I have a paid account in Claude. You can try out any AI that you want. You can try this AI prompt yourself.
Okay. Chat.
I'll just share it in chat. This is the AI prompt. Okay. Just share it in chat. I'll just share. I shared that. So the prompt was, what is the code for custom CRS? CRS is Coordinate Reference System CRS projection for a globe in QGIS. And it says for an orthographic globe projection in QGIS, you define a custom CRS using a proj string. A proj string is nothing but a projection string, and this is all text. So that's why it's called a string. Okay, projection string. And here's the formula for it. So we're going to say declare that this we want what this is basically projection. This says ortho, and you have lat long. We mentioned the lat long. We also mentioned the x y. X is 0, y is 0. DTAM WGS 84, which is basically a type of coordinate reference system that we refer to. Units would be in meter, units M, and no definition, as in nothing else. This is all that I would like you to do. That's what I'm saying to QGIS. So what I'll do is I'll just copy this code and I'll share it here. I'll share the code here and just copy this code. Just copy this code. I'll copy it from here. You copy it from the chat section. Just copy this code. Come to QGIS. And now you come to settings. Okay. Come to settings. Custom projections. Custom projections. And here you have this plus sign. This is going to open options user defined CRS. This is going to open here. You come to plus new CRS. You can name it Arctic circle. So that we have a reference. And in the format, go for prod string, because remember that the AI prompt also said prod string. So that's what it is, prod string for format. And now just if the cursor is missing, just click on this blank here and then the cursor will start blinking. Paste it. Paste this, and that's the code, by the way. Click on validate. The projection defined is valid. Okay. And then click on OK. Okay. And nothing happens because this custom projection is now stored in QGIS, but we haven't explicitly asked QGIS to show this projection. So now what we are going to do is we're going to come to projection EPSG 4326, click on that. Okay. And we are going to go for, we have named it Arctic circle, if you remember. Arctic.
Could you please do that again? Where do we click?
Yeah, just 1 minute.
Before that.
So you click on this EPSG 4326, that's going to be the projection place for you. So anytime you have to work on projection, that goes for the whole class. Anytime you want to work on projection or you want to change projection from 4326, which is flatter, to something else, this is where you come. And this is going to say, so right now, EPSG 4326, that's the default projection that we are using. So click on that EPSG 4326. Either you can search Arctic circle. I will show here in user defined, or in case you have just forgotten what you had named, what you do here is all these predefined coordinate reference system come to user defined. This is where we had defined the projection by the user. Click on Arctic circle, apply. I'm going to click on OK. Just give it some time. Yeah, but this is not exactly Arctic circle. This is just like a random area on Earth. For Arctic circle specifically, let's see. So there's a slight change. You see, like from 0, now we are saying 90. So just go ahead If you want to, I'll just copy this in the chat. Copy this and come here. And what I'll do is again go back to settings, custom projection, and either I'll just delete this. We'll start from first. We just delete this projection altogether. Yes. And now we're going to click on this for a new projection. That's how you add a new projection, a custom projection. And this one we are going to call Arctic Circle. And we're going to change this to broad string. This is very important. Always change the format. Save it, just paste it, validate it. This definition is valid. Okay. And now we're going to go
How
for
how you did
just 1 minute. Let me just show and see the map. The map position also change, and hopefully this. So now we have the Arctic Circle. Now we have the Arctic Circle. So let's just let it load a little bit. Yeah. So now your whole story is based on, see how your point of view also changed. So now we're only focusing on the Arctic Circle, which is where the red part is. Any question? Someone had a question, right?
yes, how you named the link?
Link as in like named the custom projection.
Yes, sir.
So if you come to custom projection, you see here is the name, right? So
Yes.
here the name. So just go ahead and just write whatever name you can write it. You can save it as Arctic Circle only, like because that way you will have a reference point that okay this
Paste the link, add, and you pasted the link.
sorry I didn't get your
So,
link.
yes, sir. So I went to the ad and pasted the
Link for what?
link for the article, Arctic Circle.
Hello?
Am I audible?
Yeah.
So I have pasted the link for Arctic Circle, but then I'm not getting the name. How to do that?
Okay. So you come to projection, you have saved all that, right?
Yes, sir.
Yeah. So here basically, so you're done with that, you have done the validate and then you have clicked on OK, right?
Yes, sir.
Okay, so now if you want that, you come to, so you come here. So right now it must be saying EPSG 4326, right?
Hmm.
Does it say EPSG 4326? Like this small button here on your, I think this right side corner.
4326. Yes, sir.
So click on that, and this thing is going to open. This will open the project coordinate reference system page. In filter, just search for Arctic Circle. Does it show Arctic Circle?
Hmm.
Does it show Arctic Circle?
No, sir.
Just come to user defined, then just see predefined coordinate reference system. Here you have the user defined. In case others are open, so you might have to scroll down like this, and there you will see user defined. Is it there under user defined? Anyway, so all this is recorded. So just you can just
One
follow.
question I have.
I didn't get the user defined.
Yeah.
One question I have. So why
Yeah.
did we created zonal statistics? Because I mean, we ultimately you created that and then you made it like completely transparent. So we came to the same map which was there earlier.
Yeah. Very good question, sir. But I'll just answer your question.
Okay.
So, what I'll do is I'll just revert. But this is how you can do projections. Like if you have any custom projection that you want to do, I just wanted to show you this how you can play around with like the polar regions on Earth. and a bunch of other things that you can do with projection. But let me just revert back to something like this here, Malveed. That's the projection that I would like to export the map in. Okay. Yeah. So to answer your question, sir, why did we revert back to zonal statistics? To answer your question is, we just needed the data for it. Okay. But very good question. Now I'll show you what all you can do with just the zonal statistics file. So I'll just right click on that properties. If I had to color it, come to categorized. And the same thing that we did with count poly, we did with that fire activities file, if you remember, we did a choropleth map, right? You can do a choropleth map with this one as well. Value, and then click on classify, minus. Leave it red, click on apply. And now you have a map, something that looks like this. Okay. So you can do that as well. But I'll suggest you to just follow along and just export the map the way that I'm showing you to. Because right now, right now you have the zonal statistic, this choropleth map, right, of continents. Your assignment is going to be on countries. And you have to export that map. Okay, right now we're going to export the raw data map only. But during the assignment, what you would have to do is you have to export this map, but based on countries. Okay, that's the difference. And how you color it is like I showed you, zonal statistics, properties. Come here, just check the value, like which column it is, which is the mean column, do the classify, just do all that, then apply and okay. That answers your question, sir?
Yes.
Okay. So now the final step is we are going to export this map, and the steps are pretty much the similar, except like the treatment part of it, because this is a raster file. So there'll be subtle differences in exporting it, but most of the things remain the same. And the way you do it is, if you have this thing here, new print layout. And by the way, this is the project toolbar. In case the project toolbar is missing, you can just right click and you can get the project toolbar here. Yeah, here's the project. Just check this project toolbar and you're going to get this new print layout here itself in case it's missing. And by the way, if you can see, like you can just view your manage layers toolbar from here as well. You can see the manage layers toolbar here. So you can just right click on this and you can do that instead of just going to view and just navigating to all the other options. That's another way you can view things here. So I'll just go here. In case this is still missing, you can come to project, new print layout. This is the one that we want, and it's the same thing here. Either you can do it from here, new print layout, or you can do it from here, new print layout. Click. And name it world warming 2 degrees. Content. Click on OK. And this thing is, does it look familiar to everyone here? Or is it a new thing that the class is coming across?
Familiar
Yes.
to yesterday's map.
Need a vector also.
Sorry? Okay. Can anyone tell me how we can get the map here? Which option is it? Like, just tell me like which option from the top. Anyone? Anyone remembers how to export map? Just give it a try. It's absolutely yeah.
We have to click on the add items
Paste
Add
the item from the top.
from
six,
yeah.
6, 1, 2,
We
3,
have
4.
to do add map. Add
Yeah.
map.
Add map. Yeah. Add map. So your cursor changes, come to the edge, left hand corner edge, and just drag it all the way here. Drag it all the way here. And this almost there, it almost fits in, and that's where, like I was showing you how you can change the X min, Y min. The X, I think the Y works. What we are concerned with, I think, is the X min, and the X min, what we'll do is, so this is 181, so I'll keep the same for X min as well. So let's see. So just give it some time. Yeah, so it worked. And how do I know this number exactly? Because it's just logic. If your xy is this, your x min would be the same if you want to keep the same distance from the page. That's all I did. Sometimes you might like say like you just wanted to end it here, like this is Gulf of Mexico, if I'm not wrong. Sorry, this is Gulf of Mexico. This area I think is Baja California, this area of Mexico. So I'll just come here, I'll correspond it with what the X min says. It's 10808,348. All I have to do now is just come here in X min and I'm going to type that number. That's how you can do that. And before we go ahead, I just wanted to show you one thing. So now if you right click on this page itself, just right click anywhere here, and you see page properties, you will see page properties and item properties. Okay, so the item properties is this. This is what item properties is. Okay, so you have the scale, the layers, extents, and everything. And I just wanted to show you what the page property does. So like if you right click on page properties, you can change the height and the width accordingly, and if you want the background or not. So that's the difference between a page property and an item property. And if you want to move back to your item properties, again right click item properties and you're back to item properties here, and you can do the extents and all. So now let's go back and now make a legend, and add a legend. We click on the legend one. And when we do this, we'll make a box here. And there's too many things. We don't want that. And the first order of the day is I'm going to uncheck auto update. I'm going to select zonal statistics and world continents. I don't need that. I'll just delete that. The map, the first thing is I'm going to name the map something that people can understand instead of just map. And it'll be temperature deviation compared to 1850 to 1900 average. And I'll just make it a double decker. That looks better. Yeah. And I'll go back. And now I'm going to style it a little bit. So the way you style it is like this. See. Symbol, yeah. I'm gonna delete this as well, the band, because I don't want this band baseline thing as well. So I'll just delete that. In case you want to figure out how I got this, like I was able to change this. In case you want to change this, you want to delete this, just double click. This thing is going to open. Just delete everything and go back. Some reason, yeah. So okay. So one thing you can do is just select that and just click on the minus sign and it will disappear. So that way you can do that. And now let's do the spacing thing. If you go to symbol, and if you put the symbol height as say 30 millimeter, yeah, let's go for 35, and width 5. So that's how you can change that as well. If you want the stroke, you can keep it be like this. You can change the stroke color as well. And what I'll do is no background first. I don't want any background. This looks way cleaner. And these are some of the things that you can do. Just I would encourage you to just fiddle with it and see it yourself how things work. Mostly happy with it. Just one last thing is the font. The font here again, come to item labels. I think I'll go with Courier. You can try your own font and group. I think this one is subgroup heading, if I'm not wrong. Let's see. Courier again. Bold, yeah, this works. So our legend is done. I'll just move it a little bit here so it doesn't overlap with any content. That is done. Now we'll have a source, and for that is add label. Source, and I'm going to write source IPCC Atlas. And ESRI for the shapefile. Sorry for the GeoJSON that we used. And yeah, we are good here. And I'll just change the font again. The font would be Courier. And I add a scale bar. Some people had some issues with the scale bar, and in case this kilometer doesn't work, what I'll suggest is, see, so now I'm also getting an error here. I'll just like drag it to show you. Invalid scale. Scale cannot be rendered due to invalid setting. Maybe there's some issue with the setting. So we need to change the setting here. And all we have to, how do we change the setting here is just scale by units, map unit. Let's see, kilometers. Okay, so kilometers is also showing yeah. Feed, it's also showing. So I think the map unit is the only one that's working here. And I'll just like style it a little bit. Width segment width. Keep it like this. This works for me. I'm happy with the scale. And one last thing is, I'll just drag it down a little bit. There's space for the heading. So what's the heading going to be? What is that one thing that the one thing that we took from here? Ma'am, you want to give it a try? Like, what is the story here now? What does it say?
I think let people write this on the chat. That will be better.
Yeah.
Get
So
number of
can
ideas.
anyone give it like just can you just mention in the chat like what is the takeaway from this data set?
So what does this indicate?
What does it indicate?
What is the key message that you would like to give out based on this map that you have just analyzed?
North Pole will become habitable.
Okay, by how much?
No, what I'm saying is North Pole will become habitable because of the 8 degrees rise.
That's reverse psychology working. Yeah. Reverse psychology working. Wise warming with
That is
respect
fine.
to so that we have it in the legend. Okay.
That's already there. So that's
It's
not
already
the story.
there. Yeah.
That's not the story.
Again, like that is
Again,
like what
we can say like some areas could see like temperature warming like as high as 8 degrees.
Which area?
Which area? Or like so we took so we did the analyze the data for continents, right?
Okay, vulnerability of polar regions.
Polar
Again,
region.
that is again very vague statement to make. And that because just assume suppose you have got 10 news articles on this, they all will use the same title, but here you have got the data to make your story a bit
Nowhere
different.
to survive, I think we can say nowhere to survive because all areas are going to get like warming.
Give the evidence. It's just a statement. Give the evidence.
Yeah, it's here, correct. So you have like 0.6 to 8 degree.
Okay, that's how much?
Anyone else wants to have a go?
What's the range?
We just analyzed the continent data, right? And what does
Yes.
the continent say?
Yeah,
Yes.
North America is going to the
Warming the highest.
Yes.
Thank you, Sejal. North America is going to be warming the highest. I'm going to just copy paste it.
So,
Maybe one feedback I have on this, because in this projection you don't get that unless like you have the average of the continent and then the plot that you created, correct? So in that plot, yeah, we could see that North America is the
You're right.
but when you showed this chart to all the class, like class was coming up with different answers.
Yeah, you're right. You're right. Actually, we should have exported the scoreclip map only.
The mean one, yeah, the choropleth, yeah.
Yeah, we should have just exported this this map
Yeah,
instead.
here you can clearly see, yes, I agree.
But what I wanted to do, what I wanted to do was just like for explanation purposes, I tried to export this raw data.
Yeah.
That's just for explanation purposes, nothing else. But you're right. You're right on that front regarding that. But again, like when you are doing the assignment, you have to export the choropleth map, right?
And so
just
that's the
remember
purpose.
that.
So not just exporting, but
Yeah.
we should have a graphic, a map with the story that you want to convey. Okay, with at least two statements
Yeah.
based on this.
Yeah. And for the font, I'll change the font here to.
Since we have people from Africa, we have somebody from Suriname, we have somebody from different people from different states of the country,
Yeah.
different states.
Some from
Yeah.
America.
Yes. So it'd be really good to see how people from across the world.
Across the world. So that was our reason behind this data set, choosing this data set. And also this is a very good data set to get you started with. There is something not very complicated and something that people will understand.
And this is the right time to talk about these issues with this Iran and
with the
Iran and US war
happening.
So
that's that. I think gonna be warming the highest. And now I'll just go ahead and export it. So export as image. Just save. Yeah, so we'll just open that.
So as Ply is working on this, I have an announcement to make. So everyone is expected to submit an assignment based on today's session.
Yeah, we'll give a,
yes.
You'll be getting a mail from us
Yes.
Where we'll list all our requirements for the assignment. Don't worry.
And the good news is that I know people will have some difficulty. They're all working. So the deadline to submit the assignment has been extended till 1st June to 1st June. So you have enough time to work on this after this session. And if you have any queries, you can write to us. We'll help you with the assignment.
Also, I'm just letting you know, like a lot of people do ask me, like, why has my work not been graded? We don't grade your work because it's not because we don't want to. We just want to see what you have learned. The biggest takeaway from this is what you are learning, not how much you're scoring. So that's going to be the biggest takeaway. Had I joined this session, like my biggest takeaway would be like, okay, so we have learned these many number of data formats that we can use now. There are high chances that this temperature data, a lot of people won't be using this temperature data because it doesn't overlap with their field, right? But your takeaway would be like, if I have a raster data set, how can I now quantify things? Like some of the things that you can do with QGIS. That would be the takeaway from this class.
Yes, Sajal has a question. Yes. Yes, Sajal.
Yeah, actually, it is not like connected with our today's session, but I wanted to ask. I was working with LULC maps of villages of India. So from where I can get those LULCs, high resolution LULCs actually.
So ISRO doesn't give the LULC map. Okay. We also have normally what happens is we have to calculate it from satellite data itself. Now that's a little, a little more advanced. But now that you have AI, just go ahead and just ask AI like, okay, I have these requirements and I want to do a LULC calculation. How do I do it? Just do the simple AI prompt and see it yourself. Okay.
Actually, I'm not getting the maps. Calculation is the next step, but I'm not getting the map. I tried on Bhuvan also,
Yeah,
but I didn't get.
because because normally LULC files are very heavy. Okay. So you normally
Yeah.
don't get that data. You normally what happens is people normally so ISRO has one, okay, but that's only for viewing. You can't download, you can't do anything on that. So
Oh,
that's that with ISRO. So ISRO normally doesn't share any data. So that's one red flag, a huge red flag for ISRO. But yeah.
so we can't get the village-wise LULC maps.
It's a little difficult. You have to calculate it yourself. The LULC, you have to calculate it yourself.
Okay.
I've heard
Thank you.
made available in the public domain, so they may.
So there's Copernicus. There's I'll see like where you can get the LULC, but again, like it's not going to be high resolution. Even if you get the LULC, it's not going to be a very high resolution data.
Yeah,
Okay.
I got of 250K, but that is
Yeah,
very
it's
pixelated.
if you want that high resolution stuff that you have to do the calculation yourself.
Okay. Hmm.
So and that's based out of satellite data. So that way they can like make a temporal change calculation.
Actually, I got of 10K from Living Atlas,
Okay, yeah,
yeah, but
yeah.
I was facing some problems
Yeah,
while
and those
getting
are
that.
not high resolution because I've also tried the higher. I think I'll have to see which one has that LULC. I think this one time I was trying it out myself, but those are not very high resolution ones. Okay, so I was a little disappointed with how the results came out, so I sort of flagged it. But anyway, yeah, thanks for coming for the final session. I think we'll call it a day today. This is how your map is looking, and you'll get a brief from us about the assignment. Hopefully, you were able to learn, and in case if you have any queries, please let us know. We'll be more than happy to help you guys.
So please do mail your queries to us
Queries to
and we'll
us,
try to
yeah.
answer them as soon as possible.
Yeah.
And once
Thank
again,
you.
your assignments can be given by 1st June. So
Yeah. Thank you for coming.
Thank
Thank
you,
you for
everyone.
joining. Yeah. Thank you so much.
Thank you.
Thank you, sir. Thank you, madam.
Bye, everyone.